All right, quick reminder on our Q equals MC delta T stuff. Q is energy. That's going to be in either joules or calories. M is for mass. That's going to be in grams, not kilograms or anything else, right? So for anything other than grams, we want to change that. Specific heat could have two different sets of units. It could have joules per gram degree Celsius or calories. Oops, that should be a lowercase c. You don't really see the food calories thing in there. Calories per gram degree Celsius. And then change in temperature would be in degrees Celsius for those, so that things cancel out and stuff, right? So if you're reading through a problem, you're not sure what that value is, use the units to kind of help you decipher that idea, right? So not a bad idea if you don't know those to go ahead and screenshot this and write those down or whatever, right? Or pause it. So we've got a question here. It says 32 kilocalories is added to 350 grams of lead. By how much does the temperature increase? So as soon as I read that, it tells me what I'm looking for. I'm looking for the delta T. So I know delta T is what I'm looking for. So I'm going to mark that down right away. And then I start going through those other things, right? Put that list together. If you put the list together, that's going to make life easier. So they tell me it's lead, and I notice I've only got two numbers, right? So let's go ahead and fill in the two numbers that we have. So we have 350 grams for our mass. And we have 32 kilocalories. Well, calories is a kind of energy. So I'm going to go ahead and write that down here, but we're probably going to have to change that, right? So then it tells me it's lead. Well, I don't have a specific heat, but I can't just use water as 4.18. But lead is a chemical, right? I can look it up. So I'll just look in my brain or Google or whatever, right? And the specific heat for lead is 0.16 joules per gram degree Celsius. And that's where my problem comes in, because that's kilocalories and that's joules. So I need my units to cancel. So I'm going to go ahead and change this kilocalories to joules. So we'll do a side problem there. We'll go ahead and do that in another color. As always, smart to pause me and do that instead on your own. So we'll do that over here. So 32 kilocalories. Well, to change that to calories, right, I can just move my decimal point 3 places to the right. Kilo, hectadeca base, right? So that is 32,000 calories. And then to go from calories to joules is that 4.18. So for every 1 calorie, it's 4.18 joules. It's not an accident that that's the same as the specific heat of water. Metric, calories, is based on water. Joules is based on motion. So because calories is based on water, they defined 1 calorie as the specific heat of water, right? So we just do that 32,000. Oh, this lead is going to be like as hot as the sun. I should have paid attention to the numbers I was just writing down like it was nothing. This is going to be some very, very hot lead because I don't have very much of it and its specific heat is very low and my Q is huge. Joules. So now I've got to solve for my delta T. So let's take this equation and think, how do I get that delta T by itself? If I just wanted Q, let's see, what color haven't I used? If I wanted Q, it's already by itself, but I want delta T. That's not by itself. So kind of like, let's see, 2020 equals 4x, right? Well, hopefully you can solve this, right? Well, let's just divide both sides by 4, right? So x is 5 kind of thing there, right? Well, I'm going to do the same thing here, except I've got multiple numbers there. So I'm going to take my MC delta T. I'll divide both sides by M. That gets rid of the M. Divide both sides by C. So it's Q over MC delta T. MC, that's like a DJ or something, right? Q over MC. So we take this huge number of joules divided by the mass, 350 grams, and the C, 0.16 joules per gram degree Celsius. My joules cancel out, my grams cancel out. I've got degrees Celsius under 2 bars, so that flips back up on top. So now you just have to punch those numbers in, divided by 350, divided by 0.16. So my temperature change is 2,389 degrees Celsius, which is entirely too much. That's really hot, right? That is, And that's not surface of the sun hot, but it's probably above its melting point. I don't know lead's melting point, but I'm sure it's not above 2,000. There are some metals with over 2,000, but I'm pretty sure lead's not one of them. Anyway, there's a problem for us on the Q equals MC delta T stuff.